Hello everyone, this is Dr. Babu, Assistant Professor, Department of Mathematics, St. Joseph's Institute of Technology. In this lecture, I'm going to give a brief lecture about the chi-square test, in particularly the independent of attributes. So, chi-square test, in particularly independence of attributes. Independent of attributes. So already in the previous video, we have discussed what is chi-square test and what is test statistic for chi-square test. So again, I repeat what is test statistic for chi-square test. The test statistics for chi-square test is nothing but summation of observed minus expected whole square divided by expected. This will be the chi-square test statistic formula. So here, what will be the degrees of freedom? So what will be the degrees of freedom? Degrees of freedom for chi-square test. So always the chi-square test follows n minus 1 degrees of freedom, where n is nothing but number of observation. Whereas number of observation. So always we are going to use degrees of freedom as nothing but n minus 1. We'll discuss a problem in the chi-square test. Yeah, the problem is using the data given in the following table to test at 1% level of significance whether a person ability in mathematics is independent of his or interest in statistics. So here we are going to analyze whether the interest of a student in mathematics and statistics are related or not. Okay, so interest of statistics is given and interest of mathematics, ability in mathematics, both are given in the table. So they've categorized three category. First one is low, average and high. Okay, so in this problem they given the level of significance is nothing but 1% level of significance. Using this data, we need to analyze whether there is a significant difference between the ability in mathematics and interest in statistics. Obviously, this is nothing but chi-square test. This test follows the chi-square test because so in this test we are going to analyze the interest independent, whether the given data are independent or not. So that we are going to use the chi-square test. So whatever may be the testing the hypothesis we are going to do, the very first thing is the solution. The very first thing is we need to define what will be the H naught. That is nothing but null hypothesis. What will be the alternate hypothesis? So here, what will be the null hypothesis? First, read the problem very carefully, then define what is H naught. So in this problem, what is H naught? So here they've given that whether a person ability in mathematics is independent of his or her interest in statistics. So that H naught is nothing but ability in mathematics and interest in statistics are independent. So here H naught is nothing but ability in mathematics. So here ability in mathematics and interest in statistics. Interest in statistics are independent. Then H1. H1 is nothing but H1 is nothing but alternate hypothesis. Always the alternate hypothesis is nothing but opposite to the H naught. So the alternate hypothesis ability in mathematics. Ability in mathematics and interest in statistics. Interest in statistics are not independence. So first define H1 and H0. Once you define H1 and H0, then go for uh, the what is the so actually here they given us nothing but observed frequency. We need to find the expected frequency. So here we need to find the expected frequency using this given table. So how we can find the expected frequency means just I'm taking this data in the new page. Yeah. So first find the row total as well as the column total for the given data. So find the row total as well as the column total for the given data. Then only you can find the corresponding expected value. Okay. So the row total is nothing but first one 120, 65, 63 plus 42 is nothing but 65, 105, then 120. Then the second one is 58 plus 61 plus 31. So 58 plus 61 plus 31 is nothing but 150. Then third one 14 plus 47 plus 29 is nothing but 90. Similarly, find the column total. The column total for this 63 plus 58 plus 14 values 135. Then second one is average. Sum of the average. Sum of the average is nothing but 42 plus 61 plus 47 is nothing but 150. Then sum of the value of high. Sum of the value of high is nothing but 15 plus 31 plus 29. 29 plus 31 is nothing but 60. 60 plus 15 is nothing but 75. Then find the grand total. The grand total is nothing but 360. Okay. So once you find these values, row total, column total and grand total, then we need to find the expected value for each observed value, each given observed value. So here the first given observed value is nothing but 63. We need to find the corresponding expected value. Suppose, yeah, fine. So for 63, suppose you want to find the expected value for 63 means you can find the row total as well as the column total. So here the corresponding row total is 120 and corresponding column total is 135. Okay, and the grand total is 360. So that the first one, for first one 63, the expected value for 63 is nothing but 135 into 120 divided by 360. This will give the corresponding expected value for the given observed value. So that you can use the calculator, scientific calculator. The value is nothing but 45. Okay. Second, yeah. Suppose second one, change the color. Second one. Suppose you want to find the expected frequency for second value 42. Okay, so here the corresponding row total is nothing but 120 and column total is 150. So that the second one 150 into 120 divided by 360 The value is nothing but 50. Then third one is nothing but 15. 15. The row total is 120. The column total is 75. Therefore, 120 into 75 by 360. Actually, here the concept is row total into column total divided by the grand total. Okay. So that this value is nothing but 25. Okay. Similarly, we can find the remaining values also for 58. So fourth one, we need to find the corresponding expected value for 58. The 58, the corresponding row total is 150 into the column total is 135 divided by 360. So that the expected value for the observed frequency 58 is 56.26.25. You can use the scientific calculator and you can get the value immediately. Then fifth one, the next one is fifth one 61. The row total is 150, column total is also 150. So 150 into 150 divided by 360. The value was 62.5. Okay. The next one 150 for the value 31. The row total is 150, column total is 75 divided by 360. So we can use the scientific calculator and get the answer. It will be 31.25. Similarly, find the remaining three values. The next one is 14. For 14, the row total is 90 by 135 divided by 360. The corresponding expected value is nothing but 33.75. Then it's actually previous one is 7. It's not 8, it will be 7. This is 8. Eighth one is 90 by 150 divided by 360. The answer is 37.5. Then finally, ninth one, the value is the row total for 29. The last value is 29. The corresponding row total is 90. Column total is 75 divided by 360. It will be 18.75. Once you find the corresponding expected value, we can go for test statistic. We know that the test statistic is nothing but test statistic for chi-square test is nothing but summation of observed minus expected whole square by expected frequency. Okay, and also the degrees of freedom. So degrees of freedom is nothing but n minus 1. So here the number of observations is nothing but 9. So 9 minus 1 is nothing but 8. So we need to find this value. We need to find the value of summation observed minus expected whole square by expected. For that we can form a table. So first one is observed frequency, expect frequency, observed minus expected whole square by expect frequency. Okay, so here the observed frequency is nothing but is given in the problem 63, 42, 15, 63, 42, 15, then 58, 61, 31, 58, 58, 61, 31, 14, 47, 29, 14, 47, and finally 29. Then find the corresponding expected frequency for 45, for 45, for 16, for 63. The expected value is 45. So here the expected value is 45. Similarly, for second one, the expected value is 50, 20, 50. For third one, the expected value is 25. Then the next expected value is 58, x 58. So here the expected value is 56.25 for 56.25. So here it will be 56.25. The next expected value is 62.5, 62.5. Next one is 31.25, 31.25. Then 33.75, 33.75. Then 37.5, 37.5. Next one is 18.75, 18.75. This will be the last expected value. Then we need to find expected observed minus expected the whole square by expected value. First one, better use a scientific calculator to get the values. Okay, so that first one 63 minus 45 the whole square divided by 45. The value is 7.200. I have used scientific calculator. You also can use scientific calculator and verify the values. Okay. The second one is 42 minus 50 the whole square divided by 50. Values 1.280. Third one 15 minus 25 the whole square by 25. The answer is 4. Then 58 minus 56.25. The value is 58 minus 56.25. The whole square by 56.25. The value is 0.054. The next one is 61 minus 62.5 the whole square by 62.5. The value is 0.036. Then 31 minus 31.25 divided by 31.25. The value is 0.002. Then 14 minus 33.75 whole square divided by expected value. This will be 11.557. Then 47 minus 37.5 will be around 9.5. 9.5 the whole square divided by E. So that answer is 2.407. Come for last one 29.18.75. whole square divided by 18.75. Answer is 5.603. Then find the sum of the value. So if we sum all these using scientific calculator, we get 32.14. This will be our chi-square calculator value. So the chi-square calculator value is 32.14. So that we can note it down. The chi-square calculator value. Chi-square calculator value is nothing but 32.14. 32.14. Once you find the calculated value or test statistic value, then we can find the table value, chi-square table value. Already we know that in this problem they given that, see, in this problem they given that the level of significance is 1%. So the level of significance is the level of significance is 1% level of significance. Okay, and we need to find the table value for chi-square test at the 5% of significance and degrees of freedom. So here in this problem, the degrees of freedom was, what will be the degrees of freedom? Degrees of freedom is nothing but 8. Okay, so degrees of freedom is nothing but 9 minus 1 is 8. So find the chi-square table value for 1% level of significance and degrees of freedom is 8. Use the chi-square table to find the chi-square table value. So here for this problem, the chi-square table value is nothing but, sorry. So here, since it is the attributes, independent of attributes, the degrees of freedom is nothing but row minus 1 into column minus 1. If it is only one data observed value, we can use the degrees of freedom as n minus 1. But here the given thing is attributes comparison study. So that if you go for comparative study or independent of attributes, there we can use the degrees of freedom as nothing but r minus 1 into c minus 1. So here number of rows in the given data. Number of rows nothing but 3 and column is also 3. So that 3 minus 1 into 3 minus 1, so it will be 4. 2 into 2, 4. Okay, so degrees of freedom is 4. So here we need to find the chi-square table value. Chi-square table value for 1% and degrees of freedom is 4. Use the chi-square table, we'll get values 13.277. Once you find the table value, then obviously go for the comparative study. Okay, so here we have find the chi-square calculated values. Chi-square calculated values is nothing but 32.4 and chi-square table values 13.277. Okay, so just compare table value. Here the calculated value is greater than table value. The calculated value is greater than table value. So that obviously, if it is, keep a note. If calculated value chi-square calculated value less than chi-square table value means always it will be accept H0. This will be standard result. But here the chi-square calculated value is greater than chi-square table value is nothing but, so here it will be reject H0. Okay, reject H0. Reject H0 means write on the final conclusion. The conclusion is based on H0, what we have defined in the first step of the given problem. Okay, so here H0 is nothing but ability in mathematics and interest in statistics are independent. Okay, so finally write down the conclusion. Conclusion is nothing but the interest, the ability in mathematics, the ability in mathematics, ability in mathematics, and interest in statistics, interest in statistics are independent. So just write down what is H naught here. In the conclusion place, just write down what is H naught. So ability in mathematics and interest in statistics are independent. Okay. So in this lecture, we have discussed what is chi-square test, where we can apply the chi-square test independence of attributes, and what are the advantage of chi-square test. Those things we have discussed in this lecture. Okay, so in your real life problem, suppose wherever you want to check the attributes or character, there we can use the chi-square test. Okay, so in the chi-square test we have two types. One is chi-square test for independence, other one is chi-square test for attributes. Okay, fine. So I'll give you the another problem. The next problem is, in an investigation into the health and nutrition of two group of children of different social status, the following results are got and their economic conditions. What are the conclusion can you draw from the following data? So here health and social status is given. Okay, so here health we have three types. First one is below normal, normal, average, above normal. In the social status we have two types, poor and rich. Okay, and here itself they in the sum itself they given the row total as well as the column total. So here the grand total is nothing but 480. So in this problem also we can solve what we have discussed in the previous problem. So solution is nothing but first we can define H0 and H1. So for this problem the H0 is nothing but to check the what we need to check. They ask us to check the investigation into the health and nutrition of two group of children of different social status, so that health and social status are independent. So we can define H0 as health and social status. Health and social status. Social status are independent. Health and social status are independent. And H1, H1 is nothing but health and social status are not independent. So just H1 is nothing but uh, opposite to H naught. So here it will be health and social status are not independent. Okay, so once you find H naught, H1, so here the observed data is nothing but 130, 20, 102, 108, 24, 96. Okay, we need to find the corresponding expected value. Okay, so as we discussed in the previous problem, we can first find the corresponding expected value. For first one, 130. For the value 130, we can find the expected value. It will be the row total for 130 is nothing but 150 into 256 divided by the grand total is 480. The value is 80. Similarly, second one, the value is 20. The corresponding row total is 150. 150 into 224 divided by 480. The value is 70. Similarly, we can find the second one, 102. Sorry. For the value 102, the corresponding row total is 210 into 224 divided by 480. The value is 112. Can you use a scientific calculator to find the calculation? 112. Then next one, 108. The corresponding row total is 210 into 224 divided by 480. The value is 98. Then go for next one. For 24, the row total is 120 into 256 divided by 480, value 64. Then for 96, the row total is 120 into 224 divided by 480. The value is 456. Value is 56. Okay, so that next one we need to find the test statistic value. We know that for test statistic value, we need to find observed minus expected, observed, expected, observed minus expected, the whole square divided by expected. So here the observed frequency is nothing but 130/20. So it's nothing but 130, 20, 102, 108, 24 and 96. 24 and 96. Then the corresponding expected value is 80, 70, 112 and 98, 112 and 98, 64 and 56. 64 and 56. Then you can find observed minus expected whole square by expected values 31.250, then 35.714, 102 minus 112 the whole square by expected value 0.893. The next one 1.020. Next one 25.000. Then 28.571. Okay, then once you find these values, then find the sum of observed minus expected frequency the whole square. So here the sum is nothing but if we sum all these values, we'll get 122.449. This will be is nothing but chi-square calculate value. Once you find the chi-square calculate value, then we'll go for table value. So here the chi-square calculated value is nothing but 122.449. Okay, so here the level of significance is nothing but is not given, so that will be 5%. So here the level of significance is nothing but 5%, and degrees of freedom. So here degrees of freedom is nothing but rho minus 1 into column minus 1. So here the number of rows. So in this problem, number of rows is 3 and column is 2. Number of rows 3, 3 minus 1, column is 2, 2 minus 1. So that degrees of freedom is nothing but 2. So that chi-square table value for 5% and the degrees of freedom is to find the chi-square table value, that will be 5.991. Okay, then compare calculated value and table value. Chi-square calculated value, chi-square calculated value is nothing but 122.449 and the table value is nothing but 5.99. So chi-square table value is greater than chi-square. So here chi-square calculated is greater than chi-square table value. Therefore, we can say that it is reject H naught. Reject H naught means already we have defined what is H naught, which means that health and social status are not independent. So in this problem, they have given the conclusion as the health and social status are not independent. So likewise, whatever be the problem given, first check whether which category or which test we can use for solving this problem. If it is testing the independence of two group of people or two categorical data, then there you can choose the chi-square test to analyze the given data. Then first find h naught, define h naught h1, then find what will be the expected value if it is not given. Once you find expected value, then we can find chi-square calculated value, then chi-square table value, then finally write in the conclusion. So in this lecture, we have learned the concept of chi-square test for independent attributes. Okay, these two problems will be helpful for solving the other problem also. Okay, thank you.